up if you've heard of itch mites, okay? If possible. Okay. And of those people, also raise your hand if you live east of Route 59. Okay. All right. And that's pretty many of the people that have heard of itch mites have lived east of Route 59. How many, now you can sit down. How many people, now let's have the people that have not heard of itch mites stand up a second. And how many, my hypothesis is that many of you will live west of Route 59. How many of you live west of Route 59 in the group? Okay. That's my blunder for today then. Okay. All right. So that didn't prove out in a sense. I think we're kind of heavily loaded to people that live east of 59, and some have heard of itch mites and some have not. Let me try this in a separate way. How many people had cicadas in your area? Heavily amount of cicadas in your area? During this spring outbreak, yeah. Almost everybody. Okay, we have a non-representative sample. Are there people that lived west of 59 here? I didn't see any that said that yet. Anyone live west of Route 59?
We do.
Do you? And did you have cicadas in your area?
No, one of the things we heard is your house needed to be 30 years old or so, and our house is only 20 years old. To have the ground populated by their larvae.
Okay, all right. Yeah, if they're on a 17 or a 13-year cycle, like they are more of the 13-year cycle are around here, then obviously if you weren't in an area where the cicadas were 13 years ago, they wouldn't have left their eggs around here. Itch mites. Who has actually had a personal experience with itch mites? Okay. Does anyone know where I'm going with this thing? What can you say about that?
Well, evidently the itch mites are a curious little creature that derive their nourishment from the larvae of the periodic cicadas, not the annuals. Thank you. And
So far you said that they're curious animals that derive much of their sustenance from the larvae of other animals.
Periodic cicadas.
Of periodic
specifically.
cicadas,
Yeah.
right.
So there's a lot of them right now, and their bites are very, very nasty, but fortunately they don't derive any nourishment from us.
So they can't keep it going, huh? Yeah, if you've noticed that you may have, and they're often on your arms, right, and upper arms and necks and so on, they can be reddish bites. I think my wife thought for a while we had an infestation of bed bugs or something like that. It was pretty nasty. I had one on my crook of my elbow right here that was and it lasted and it got very red. I could show you some more, but I don't know that we will make that rating that we need to on YouTube to keep in business here. But
Pretty big. It reminded me of like, sort of a Lyme disease where you get red dot.
yeah, John's saying they start out as just a dot from their bite, and then as you itch them, hence their name, itch mites. You scratch them, and you get a pretty good size, almost the size of a silver dollar red mark on you. So, and they basically, like was said, they grow and they harvest and feed on the larvae of the eggs that are laid and the larvae that are laid that come from the cicadas. So if you've been doing outside work, which is another way I could have gone as we tried to do this, if you've done outside work, a lot of gardening, or if you're moving brush, you're very likely to have the eggs that fell from the cicadas drop down into the ground. The itch mites are around in there, and you're very, very likely to have had that. And so I was trying to come up with some level of hypothesis and to see what went on with itch mites. But I've had a group of people that I ride bikes with, and all of a sudden everybody started talking about these itch mites, and then you can see if you Google it or look at it online, you can see the story of itch mites and how they're prevalent right now, and they're going to drop back down again. There's going to be a crash in their population, right, as time goes on. But right now, they're at a high prevalent time, and they're looking for anything to feast on, and it was very good. I didn't hear that they are not really deriving any sustenance from them, so we can hope that they'll learn their lessons and move on to other feeding things.
And I can't confirm it, is there's so many, because the birds fatten up on cicadas and they usually eat mites, so you have an overflow of mites.
There's an overflow of mites because birds have fattened up on cicadas, since,
Right, because they got so fat they didn't have to eat the mites.
so they're not eating mites. Okay, so that's another pressure on their population right now. And there's interesting things to do about populations of different kinds of animals. As wolves got away from Yellowstone, were taken away from Yellowstone by hunting, then the population of elk and deer, spread enormously, and they started starving and different things like that, crashes and rises in their cycle. There's another question or point back here.
So I don't have to worry about that thing popping out of my head or anything, right?
It could be a brainworm, but I haven't really done the studies on brainworms right now.
I think somebody's been watching too many movies.
So anyways, if you've had some, for a while there, it was just me thinking something for a while about this, and kind of odd, and then Jane started mentioning it too, and she had it, and then, you just kind of hear about more and more people about it, so it was interesting to see. Yeah, now we're all going to be sitting here itching through Science Sunday, so. But, interesting phenomenon, and you can Google itch mites and find out a lot about them and how they love to feed on us. All right. Thanks for coming to the first Science Sunday of our new year. Paul, hi. Haven't seen you for a while. Nice to see you. First Science Sunday, the new church year. Last year, we were able to get back to meetings like this in community, sitting in here, and you can't imagine how much that meant to both Scott and me to be able to talk to people and interact and go back and forth. That meant so much to us. So we fondly call this our clubhouse, and so it's a nice place to meet and talk about our topics. After almost 3 years of remote meetings, so that was a great thing, and I thought it was a fantastically culminated by the return of our Science Slam, which we were able to do, and the fun of that, hearing people talk for 10 minutes or so about a topic of interest to them, and we had some very, very amazing topics and a lot of fun with that. It was a rousing success. We thank this church for providing us with this physical space and the congregation of a group of people with interesting ideas and interests, and that they support us in our search for truth and meaning, and provide us a place where we can kind of intermingle and talk about different topics. So thank you all for your years of participating and being involved with this, and it continues to be a lot of fun for Scott and I. So thanks to you for all that. I had kind of three purposes of this talk. It's based on a book called Brilliant Blunders by Mario Livio, who's a great author, science author, and a scientist himself. And my points were, one, is kind of an interesting way, a backdoor way to review Darwinism and all its strengths in explaining the natural world. I wanted to also maybe talk and introduce you to the blunders, introduce you to some interesting fallacies in his Darwin's logic, and how he came to points of view that were not always supported completely by facts, but he soldiered on. And also kind of to talk about blunders and their purpose in scientific growth of knowledge. We kind of, maybe from high school or reading things, you read about these fantastic guys, Louis Pasteur, who went out there and checked all the farm sheep of France and found out, about anthrax and all these different fascinating, amazing things. And the stories are built up in ways that make you think this was just a person with amazing capabilities and sense, and they are. But there's also the struggles that they had as well, too. So this is a little bit of a way to talk and to look at that. So I I wanted to address the topic of those blunders first, and then go on with some other things as well, too. This is an interesting artist's conception of what the Mars Climate Observer, floating over the artist's conception of Mars in beautiful orbit, checking out, doing all these fascinating topics. It was sent up in 1998 and reached Mars in 1999. And the story of the Mars Climate Observer is that it failed entering orbit, coming into orbit around. So it was lost September 23rd, 1999, so just about 25 years ago. During a maneuver, it was set to attain orbit around the red planet. Hi, Carrie. Investment in this project was about $600 million in money, nowadays money. And it flew for 9 months, got all the way to Mars, got sent directions as to how to get into orbit, and it immediately was destroyed. They don't even know for sure if it just plowed into the red planet or if it burned up in even the minimum amount of atmosphere that Mars had, or if it just slingshotted off somewhere. They never were able to really locate it with the technology they had at the time. So it was a failure, and this thing with a lot of money and scientific expertise and knowledge and everything was expended to get this thing there, to try to get more knowledge about the planet that we would have used continually, scientists would have used to further our knowledge, and it definitely delayed the exploration of Mars by the failure of this thing. Does anyone know what happened and why it happened? It was, yes, it was an improper conversion. Someone working for NASA came up with a force unit of what speed and what force had to be applied to break this the satellite, break it in terms of BRAKE, to slow it down. Not that they did the other kind of break, but they were trying to put the brakes on it to slow it down, and their conversion was sent in American units, and NASA assumed that the units came in metric units. So this shows the planned trajectory was supposed to come in about 226 kilometers above Mars. So not perfectly to scale, but and it actually came in about 57 kilometers above Mars, which is about 35 miles. Still pretty high, but the math was all wrong, and everything went downhill from there, as they say. So improper things based on one small blunder, right? Mistake. So that's kind of the idea of blunders I'm talking about here. Blunders, I thought, I've looked it up, and could be described as a gross error or mistake, usually caused by ignorance, carelessness, or stupidity. So, yeah. And we've probably all been involved in blunders at some time and seen other people commit them right near us, probably even, right? Not that any of us have ever done it. But. And people, there's been studies, and another scientific area of study that's interesting is how well adapted humans are to find blunders in other people, right? And miss the blunders that are in themselves, too. So it's an interesting topic, more of a psychological study. But if we keep that in mind as we talk about it, ignorance, carelessness, or stupidity, and people attribute it very wildly to the third one very often, when it's in someone else. Right? There. Here's some famous scientific blunderers, and if you're interested, if this is a topic of interest, we can talk about it. William Thomson, well known for his work in physics. He was born in 1824 and lived into the 1900s. 1907 he died. He was named William Thomson, but he was elevated to the House of Lords in 1892 based on his scientific work. So he did a lot of amazing stuff. The Kelvin scale, He's the first person that determined what absolute zero is, what temperature that actually is. He invented, or developed, explored, or explained the first and second law of thermodynamics. So had a lot of successes to his name. But there's some interesting things that actually happen to do with evolution that he was a big part of stopping the spread of the theory of evolution because of some of his work. He was involved in many different things, but the thing that he was involved with that got him involved with evolution was he was asked to determine the age of the Earth. And he used his knowledge, immense amounts of knowledge, to determine how many years old, and he said it couldn't be more than a few million years old, right? And we can go through and talk about that. Fred Hoyle, does anyone know anything about Fred Hoyle? Hoyle? Cards, no? Different Hoyle, that was his brother. Hoyle? Hoyle was a famous astrophysicist. He was famous on the BBC radio show of making fun of a new theory about how the universe developed, and he derided it and called it some kind of big bang, and so he was very negative about it, and actually a lot of the things that he intended and wanted to stay with, the solid state theory of the growth of the universe and so on, were eventually disproved. Linus Pauling, only person to get two individual, without any other person involved, two Nobel Prizes. Okay, he was a famous chemist. He was involved in the discovery, did a lot with benzene, did a lot of other things about, I think he's helped develop the first understanding of microstructures and diseases. So he was involved with sickle cell anemia, development of the molecular structure of things that cause that. He won 2 unshared Nobel Prizes in 2 different disciplines, right? Anyone know ideas about what he was involved in? Chemistry, and not biology. He got the Peace Prize. He was one of the scientists involved in working against the development of nuclear arms and so on. So very, very involved with that. So again, many successes, many great developments, yet he had some mistakes with him in terms of developing DNA, the structure of DNA. Einstein, there's not much that has to be explained about him. Born in 1879, and he lived till 1955. Most of us were alive when he was around as well. As Hoyle died in 2001. And so Einstein, with a lot of great successes, and maybe you've heard of some of his kind of blunders and things as well too. But so part of if you're going to be on the playing field, you're going to make some mistakes once in a while, is the basic idea, I think. So Darwin was on the playing field, obviously, in terms of evolution and science, and so we'll talk a bit about his blunders. Okay, it's part of the path of science, I guess, is my point. They're not only inevitable for everyone, but they're also an essential part of progress. They can often act as catalysts for impressive breakthroughs. Some of these blunders can be just eye-opening when looked at in a different way. Or they can serve as the agents that lifted the fog through which science was attempting to progress. Those who can recognize and overcome the difficulties often achieve spectacular results. So this is not in any way, intended to denigrate or put down their thoughts. It's just that if you're on the playing field, if you're trying to do stuff, you're going to have mistakes, and how you act and deal with them is critical. So, just a little bit to talk about his blunder. We have to maybe talk just about his theory and so on, and what he went from there. This is, usually you see the photos of him with the long beard sitting quietly in his garden or something like that. This is a photo I chose because it takes him from 1854. This is just about the culmination of his work and his efforts on publishing the The Origin of Species, which came out in 1859. So this is how he was at that time. He was a kind of a hypochondriac. He was very sick in many ways. He lived in the country and tried to stay away from other people at times, but he did these wet sheet healings where he went to baths and got wrapped in wet sheets and they doused him with cold water, and that was all supposed to help make him feel better. And I don't know, maybe, yeah. In some cases it works. But, so anyways, that's him in there. And just to get to some background about the whole idea. And basically the thing that is maybe puzzled all humanity for eons has been something about this: why is there such prodigious diversity of life on Earth, right? So it begs some kind of explanation. Why are we so different as people? Why are different species so different? Why are there itch mites that jump into our skin when they can? And why are there cicadas that come around every 13 and 17 years? You think of the prodigious diversity in life, and it begs an explanation. There's somewhere close to 10 million species of life are currently living on Earth. That's just an estimate because obviously we haven't been able to catalog or categorize most of them. 80% of them have no official names, maybe haven't been identified in any way. It's pretty well known that there's an amazing diversity of different kinds of life, and that the human brain, with all its efforts and computers and everything else, can't even categorize the amount of creatures that are here. Plants, animals, living things, right? This incredible idea, incredible degree of adaptation. When you think of woodpeckers and trees, right? Here's trees that bugs get in somehow, and now woodpeckers are developed with the strength of muscular structure and their beaks and their skull strength that they can actually get there and get the bugs out of the trees and survive, right? This adaptation that allows them to do that. Bees and flowers, how flowers seem to be especially designed so that bees crawling in them will get the pollen on them and then go fly onto other flowers and pollinate, right? Cross-pollinate. When you think of that, how can you explain how there's a flower of exactly the right shape that a bee getting in there, will get itself all coated with pollen? Or the whole story of hummingbirds. Darwin talked about when he saw a flower, I think it was from Mauritius, an island off of the coast of Africa, and it was 10 inches down to where the pollen lay. And he said there has to be some kind of animal, there's got to be a hummingbird or some kind of creature that can get in there that has a 10-inch long tongue. And it wasn't for 100 years or so until they found this creature, but it was found. So they pollinated these plants, in these ways. So all these adaptations. When, who's the guy that did the story of the Titanic? Cameron, yeah. He went down to the bottom of the Marianas Trench. At the bottom of the Marianas Trench, it's not a living thing. There's a trench down miles deep in the ocean, 37,000 feet, I think, deep. He found shrimp-like creatures that were down there that had adapted to that lifestyle, that type of situation. So, when you think of all these different things, and you could come up with hundreds of examples of this, if not thousands or more, this incredible degree of adaptation and the capacity of different living things or living things to adapt to a non-living environment like just the bottom of a trench in the ocean. So really, the answer for many years was some kind of divine reason, right? I've got a quote from Cicero from the 1st century BCE. He said that the natural world had to stem from some divine reason. If all the parts of the universe have been so appointed that they could neither be better adapted for use nor be made more beautiful in appearance, if then nature's attainments transcend those achieved by human design, and if human skill achieves nothing without the application of reason, we must grant that nature too is not devoid of reason. So his explanation was reason, that there had to be some purpose, some design to it. He also, and this is interesting to me, was the first to invoke the whole clockmaker metaphor. And that later, in the 1st century BCE, you can develop a clockmaker metaphor. So he wrote, "It can surely not be right to acknowledge as a work of art, a statue, or a painted picture, or to be convinced from distant observations of a ship's course that its progress is controlled by reason and human skills," right? If a ship is going a certain direction, and it is a logical, reasonable direction, you'd think that humans have to be involved in that. Or upon examination of the design of a sundial or a water clock, to appreciate that calculation of the time of day is made by skill and not by chance. Yet, nonetheless, to consider that the universe is devoid of purpose and reason, though it embraces those very skills and the craftsmen who wield them and all else beside. So he brought the water metaphor in the 1st century BCE to talk about divine reason for why all these things are there, why there's woodpeckers and trees and different things like that. And how many people are familiar with William Paley? Have you heard of him? He may have come up in high school biology classes or whatever, but he was a minister, and he wrote, and actually Darwin had read a lot of Paley, and he makes a very cogent argument. It's a very well-reasoned argument. And he adopted this argument 2 millennia after Cicero. A contrivance, like a watch, implies a contriver, just as a design implies a designer. An intricate watch, Paley contended, attests to the existence of a watchmaker. Therefore, shouldn't we conclude the same about something as exquisite as life? After all, and here's Paley's quote, "Every indication of contrivance, every manifestation of design, which existed in the watch, exists in the works of nature, with the difference, on the side of nature, of being greater and more, and that in a degree which exceeds all computation. This fervent pleading for the imperative need for a designer, since the only possible but unacceptable alternative was considered to be just fortuitousness or chance, right, convinced many natural philosophers until roughly the beginning of the 19th century. So that's kind of also the argument of people saying, can you imagine in a scrap heap in Arizona, a giant windstorm comes by and starts blowing all these parts around in this scrap heap, and all of a sudden it ends up being a 747 or some kind of airplane that could actually fly and take off? That belittles the idea that basically chance is what is the other possibility besides not chance being divine reason. Okay? So that's the whole basic concept, I think, there of intelligent design and reason, which still has prevalence today in many areas. Okay? The other thing is that species were considered immutable, not to change at all. Why would a designer create a species that would fail? If you have a designer, he's going to make something that's supposed to be there, so it'll be there, right? So there was no extinctions in people's minds, no changing, no growth, right? I've talked a few times about Platonic ideals for the ancient Greeks that worked so beautifully when you're talking about geometry and mathematics and how you figure the area of a circle and how you can figure out pi, the exact formula for pi, the exact value of pi, I should say, just by looking at the perfect circles and perfect features, right? And the Platonic ideal moved on from that, not only to geometric shapes, but also the stars in the sky never changed. They're always there. They're like they are. You can see them. They're the same yesterday, the same tomorrow, except for the wanderers, right? and living things. To Plato, a horse was a horse. And you don't see changes in horses. We don't see, we don't remember. I remember when a horse was only this tall or something like that. In human memory, in human mind, that doesn't come about. We recall the things as we see them, okay? So species were considered immutable. They figured that they had to be fakes or something when they started finding dinosaur bones, but it got to be hard to explain. And there weren't that many dinosaur bones and relics and fossils and things in Darwin's time to the extent that we have nowadays. But that was changing. Then came November 4th, 1859. Okay? And November 24th is a pretty important day. We don't remember it that much at all, but the origin of species by means of natural selection, or the preservation of favored races in the struggle for life. Okay? By Charles Darwin, M.A. So it sold out in a day. There were continued reprintings of it and so on, and it started a lot of conversation. One of the famous things someone said about Darwin was a man who was much read but more talked about. A lot of people have talked about him without reading what he's written and so on too. But so, as a recap, Darwin's theory had four main pillars. He started out with the idea of things were capable of evolving. And that had been talked about before. Lamarck, we've talked about him a little bit. He was a Frenchman at the Jardin des Plantes, the great center of learning in Paris. Used to be the Royal Gardens and then became the Garden of Plants. And great scientists were there, natural philosophers as they were called at the time. Chambers, and Darwin's own grandfather, Erasmus Darwin. He had written about evolution, and he had a famous poem that was like this epic long poem called Zoology? No. I had it and I forgot it. I'm sorry. But Zoonomia, yeah. So he took the basic idea of evolution. Things change, things adapt. He borrowed from a couple of geologists, Hutton and Lyell. Lyell was a contemporary of his and later became a very close friend. Hutton was about 100 years earlier. This uniformitarianism, this idea that things change at a gradual pace, right? Things weren't all going crazy. There weren't like phenomenal adjustments in the natural order of things. In other times, things at all times moved at a gradual pace with the once in a while explosive kinds of geologic occurrences. Okay, so that meant that sand piled up at slow rates. It wasn't some enormous thing. If you find some of these giant sand dunes that are turned to rock now, it's because the sand piled up over many, many years of time and then got solidified. So gradualism was very important for his concept to work, for evolutionary thought in Darwin's mind. And he talked about common descent, which, as he looked at it and studied it more and more, he thought there's just, when you see similarities of mammals, let's say, if you look at a group of mammals, there are no mammals that somehow happen to have, 4 arms and 2 legs or something like that, right? They all have 4 limbs, right? And those 4 limbs have upper limbs and lower limbs. They can come out with a lot of changes, but there is a common descent that you can see in mammals, and that then you can also see across species before that. How are we similar to reptiles or amphibians or fish or different things too, which a lot of our science has talked about in here too. So common descent, one single ancestor of all life is what Darwin came up with. And that was his last line in The Origin of Species. He talks about how they all came from one or perhaps a few, but everything grew and developed from that. The tree of life kind of concept, right? And the fourth one is speciation. Then as things grew, then things specialized in different areas, right? So you became a species when your capability was, when your group of organisms had capabilities that others didn't have, often not able to breed with each other anymore. And this was interesting. Back in 1945, Nabokov, scientist and an essayist from Russia, he talked about these butterflies that are in South America, Polyamatus blues. And his theory, after he looked at them and studied them, was that these butterflies were very similar, but they weren't all alike. And in fact, he postulated that they came over in different waves, that there was a wave. They came from Asia, actually, and the westerly winds blew them over to South America. And so these New World butterflies came from the ones over there, but they were very different from the ones that remained in Asia as well, too. But actually in 2011, when they started doing DNA samples and checking these butterflies, they found that some of the species that were still in Asia were more similar to species in the New World than the New World species were to each other, right? So when they came over, the first groups that came over started evolving when they were over, and they started being different. Other groups that came over at a later time and were different and had evolved in a different way. So their most common ancestor wasn't each other in the New World, right? In South America, their most common ancestors were back in Asia. And that was postulated in 1945 and then proven with DNA studies in 2011. So this speciation is a very fascinating subject. So that's basically Darwin's four main pillars. I think I'm hitting the wrong button. There. All right. Which led to Darwin's concept, and this is from his 1837 notebook. He had like just massive amounts of notebooks. He'd fill up one notebook, and then he'd start on another, and he kept them all categorized and organized. But this is 1837 notebook, which is 22 years before his publishing of The Origin of Species. And it was included in, it's the only drawing in Darwin's entire book. And if you see up at the top there, he's got his caveat. So that's pretty amazing, isn't it? And he's describing how this tree of life and how the different branches, this is some original origin species at this point, and each of these is a speciation event, right? And he's deciding and discussing differences, which is most like the other, and this one would be most unlike these others, right? And actually, I think Stephen Jay Gould called it, it's not really a tree of life. He said it's a bush of life because it bushes out, not as much as like a tree from it. So, natural selection, and I like this quote too. This is Daniel Dennett, one of favorite guys. He's actually called one of the four horsemen of the apocalypse, right?
Four horsemen of the atheist.
Yeah, he and let's go through them.
Christopher Hitchens, Sam Harris, and
Richard Dawkins, right? Richard Dawkins? Yeah. So he says it's the single best idea anyone has ever had. One of Darwin's supporters said, when I heard this, it seemed like the simplest idea ever. It made the most, he said, I don't know why I was so stupid that I didn't come up with it, right? That was his point. That it's the natural selection is the means by which you get past this whole religious designer kind of, intelligent design kind of thing. So this is in The Origin of Species in chapter 3, which is a fascinating book. If you haven't read it, I really recommend it. It's easy reading. He was aiming it for a lay person, right? But it had immense scientific consequences. Owing to this struggle for life, which he talked about in terms of Malthus and so many progeny are born that can't all survive, owing to this struggle for life, any variation, however slight, and from whatever cause proceeding, if it be in any degree profitable to an individual of any species, in its infinitely complex relations to other organic beings and to external nature, will tend to the preservation of that individual and will generally be inherited by its offspring. The offspring also will thus have a better chance of surviving, for of the many individuals of any species which are periodically born, but a small number can survive. I have called this principle by which each slight variation, if useful, is preserved by the term of natural selection. So the whole concept, Darwin's book, he starts talking about pigeons in the first of The Origin of Species, right? And he talks about how he raised pigeons and he hung out with all the pigeon breeders in South England and so on, and he talked with them, and these people were immensely proud of what they could craft, and in the number of 4 or 5, 6 generations, they could make, one guy said he could make any kind of pigeon that you'd want to have, you know, and he had illustrations of pigeons with big tufts of feathers in different places and all sorts of different things. But he made the point of what he had is by how capably farm people or pigeon raisers or different people could craft a specific trait in a species, in pigeons or peas or different things like that, just by using their knowledge and by breeding them properly. And then he went on from that with comparing that to say now with the length of time that there is involved in the age of the earth that he postulated and the capacities of natural selection, the artificial selection can be transferred over and nature can do those same things as well too. So just an eye-opening, mind-blowing kind of discussion that just captured everyone's attention. So we kind of got through 2 of my topics, and then I wanted to go where was his blunder and what went on with that. So these are kind of some demonstrations I'll have here. This is, at the time, there was not much understanding about how traits really got passed on. They could do it, like they could make the perfect kind of pigeons that they wanted. These people were fantastic in their capabilities, but they didn't understand the science and knowledge behind it. And the common thought at the time was something that goes along with this. Maybe a white flower and a red flower. And what would go on with that and the concept of that, what would happen was called blended inheritance. Also, maybe you can think of it as the paint pot theory. If you take blue paint and yellow paint and pour it together, you're going to get something different, right? You're going to get green paint. So that was kind of the concept of what would happen with inheritance. And in some cases, it does happen, right? So it's a complex field to study. Genetics has proved to be challenging in many ways, but it also has some basic ideas that we've been able to tease out of it. And blended inheritance is not how much of this happens. If you'd have a blended inheritance, if a man and a woman would have intercourse and an offspring, it would be, that's not blended inheritance. You get a trait, right? That's either a man or a woman generally, right? You don't get a half man, half woman out of it. So it doesn't work in many cases, and it doesn't work in a large number of cases. So to make blended inheritance try to work, Darwin started looking into other things. I'm sorry the color didn't come out like I hoped it would here, but in this other one, this is his ideas of what might happen. And in the body, different parts of the body could dispense tiny little particles that are called gemmules. And gemmules,